So here we're looking at another example in the discrete random variable discussion. This one says a worker is asked to perform 4 tasks, and let x, and we're here defining a random variable, be the number of tasks performed correctly. The following PMF is provided. So he's asked to perform 4 tasks, and x is the number of tasks performed correctly. Well, obviously x can be equal to 0, 1, 2, 3, or all those 4 jobs being done correctly. And the probabilities of them are given to us. So essentially, they gave us the PMF function. We know all the probabilities for all the values in the range of this random variable. Now, let's take a look at part A. What is the probability that the worker correctly performs 3 tasks? Well, correctly performing 3 tasks is probability of x equals 3, right? Or in other words, f of x at 0.3. And that is directly given to us. That is 0.1. So a 10% chance. Part B. What is the probability that the worker correctly performs at least 3 tasks? And this is the tricky part that sometimes is causing problems. When a problem says at least, that means more than equal to. Although the word least sometimes makes us think that is less than. No. When it says at least 3 tasks, that means 3 tasks or 4 tasks. So therefore, you're going to have to calculate probability of x greater than equal to 3, which is probability of x equals 3 plus probability of x equals 4. In that case is 0.1 plus 0.8, so 0.9 or 90%. Part C, what is the probability that the worker correctly performs, again, at least 1 task? At least 1 task is x greater than equal to 1. And that is 0.03, 0.05, 0.1, 0.8 added together. Or, in other words, you can say it's just 1 minus probability of x equals 0, right? It's the same thing. Because these, they have to add up to 1, and they do. So you can do 1 minus 0.02, so 0.98 or 98%. Now here's the fun part. Construct the CDF of x. We worked on a very similar problem here, and I want you to do the same for this problem. So pause the video and construct the CDF function here. So when we are constructing CDF function, it's going to be a similar list, but it's going to have a different notation, cap of f x at 0 all the way to 4. What do they mean? It's probability of x less than equal to 0 and probability of x less than equal to 1. And again, I want to emphasize here that the main difference between CDF and PMF is the sign, right? Here we had equal to, but in CDF we have less than equal. Therefore, we just need to add up the correct values of PMF. For the first one, probability of x less than equal to 0 is the same as probability of x equals to 0 because there is no other value of this random variable below 0. So that is 0.02. But starting from the second one, probability of x less than equal to 1, that is the addition of these two, right? It's probability of x equals 0 plus probability of x equals 1. And that is 0.05, right? That is 0.02 plus 0.03. Similarly, you can continue this, less than or equal to 2, that's the addition of these 3 values. Less than or equal to 3, addition of these 4 values. And less than or equal to 4 is ultimately going to be equal to 1. And just like that, you get the CDF function of this PMF.